All right. First lesson in Algebra 2, Lesson 2-1. Follow along on your notes and write whatever you would like, especially the examples. These are our learning targets. You can define relation, domain, and range. You can define a function as a relation in which each input, your domain, has exactly one output, your range. You can determine if a stated rule, graph, table, or set of ordered pairs represents a function. You can explain that when x is the input of a function, f of x represents the output of a function. You can explain that function notation is not limited to f of x. There are others like g of x, h of x, etc. You can explain that the graph of f is the graph of the equation y equals f of x. You can use order of operations to evaluate a function for a given domain or input value. You can identify the independent variable and dependent variable and describe the relationship of the variables. So a relation is a set of pairs of input and output values. You can represent a relation in 4 different ways. We have the ordered pairs, input-output, also your x, comma, y. We have the mapping diagram. The arrows show what input goes to which output. You can see your 4 goes to several outputs. Your table of values, also known as a t-chart, kind of breaks down your ordered pairs in a chart form. And then your graph is just the graph of your ordered pairs. So your domain relation is a set of inputs, all of these values, and the range of relation is a set of outputs, these values, also known as the y coordinates of ordered pairs. A function is a relation in which each element of the domain corresponds with exactly one element of the range. So for each input, there's exactly one output. So x values can only have one y value. So is this relation a function? Why or why not? I'm going to give you a second to think about that. Pause the video if you need to. So this mapping, does each x value have only one y value? Well, we see, kind of got messed up, but these are our inputs. And you notice that 2 goes 2 different places. So this no is not a function. Why? Because 2 has 2 outputs. All right, B. Ordered pairs, a little bit harder to see. Mapping, kind of easy to see if it's a function or not. You need to make sure that there are no repeated x values. So -7 only goes to 14, 9 only goes to -7, 14 only goes to 7, 7 only goes to 14, and 5 only goes to 9. So yes, this is a function. Why? For each input, there is exactly one output. All right, pause there. If you need to go back, do so. All right, so what if we are given a graph and asked if the graph is a function? We use the vertical line test. Vertical being up, down. Vertical, we want to make sure it passes that test. So to use it, you draw a vertical line through your graph. If it passes through more than one point on the graph of a relation, then the relation is not a function. So here, if you want to do it yourself, pause. We look at A. If I draw a vertical line, you will notice that it crosses my graph twice. So it fails the vertical line test, so no, this is not a function. This one, if I go through each point, draw a vertical line. Do I cross any points? Multiple points? No. So it passes the vertical line test. So yes, B is a function. And C, I can draw my vertical lines, and I don't double cross anything. So this one also, yes, is a function. So a function rule is an equation that represents an output value in terms of an input value. You can write a function rule in function notation that is pretty much replacing f of x with your y, or vice versa. So we'll go through some examples. In our y, first one equals 3x plus 2. Y is our output, and x is our input. And then making it function notation is just replacing that y with the f of x. Everything else looks the same. Plugging in a number when 1 is the input in this example, we just replace 1 with x. So you'll notice 1 replaces x in each spot. So we solve this one out. 3 times 1, 3 plus 2 gives us 5. So f of 1 is 5. So just simply plugging in whatever your input is into x. So the independent variable x represents the input of the function, and the dependent variable f of x represents the output of the function. It's called dependent variable because the value depends on that input value. All right, so let's try a problem. It says for f of x equals negative 3x plus 2, what is the output for the inputs negative 4, 0, and 0.2? So all we're going to do is plug in each value for x. So we will start with negative 4. So I have f of negative 4, and then I'm just going to copy that down. Equals negative 3, plug in negative 4 for that x, plus 2, and solve that out. Negative 3 times negative 4, 12. 12 plus 2, 14. If you want to do the other ones, take a quick second, pause this, and we'll come back and check, see if you got them right. So let's do f of 0. F of 0, plug 0 in for x. We know negative 3 times 0 is 0. 0 plus 2 is 2. So f of 0 is 2. And the last one, f of 0.2. Again, keep doing what we're doing. Plug in 0.2 for x. And we get negative 0.6 plus 2, or 1.4. So a function rule. Oh, rewind. If we want to write these as ordered pairs, inputs and outputs. Our input for the first one was negative 4. Our answer for that, when we plugged it in, we got 14. So that is our ordered pair, if it asked for ordered pairs. The second one, our input was 0, and we got out 2. That would be that ordered pair. And then the last one, 0.2 and 1.4. So those would be what it looks like if they asked for ordered pairs. All right, function rule is an equation that represents an output value in terms of an input value. So you can write a function rule as in function notation. That's pretty much saying that when a question asks for a function rule, it means you have to write an equation. So, our pizza problem. It says the pizza costs $14. The flat delivery fee is $1.50. What function rule models the total cost of the number of pizzas delivered, and then a value for 5 pizzas? So pause here, see if you can figure out, and then come back. So we need to make a function rule. So we're going to have our f of x, our equation. we don't know the number of pizzas. That's going to be multiplied by our cost of each pizza. So that's going to be attached to our x. We're going to have 14x. Plus flat implies it just gets tacked on no matter how much you order. So our 150 kind of gets thrown on at the end. Evaluate means plug in 5 for x. So what would the cost be if you ordered 5 pizzas? So plug 5 in, and we get out 71.50. So if it asks for dependent or independent, you would say cost is dependent on the number of pizzas. And that is all for lesson 2-1.